Hello class, this is Dr. Foley. I'm in my basement, so that noise you hear is the sump pump. It's been so much rain lately that it's constantly draining around our house. But this is my makeshift lab to run some online videos for you. I'll try to keep this less than 500 megabytes so I can get it on Canvas directly, but if not, I will upload it to YouTube and then post the link on Canvas so you can watch this video. But this is how we'll do some of the labs. I will post a video showing you how you would collect the data if you were actually at school. And then I will give you a report for you to complete using the data that I've collected here. So this experiment is related to what we've been talking about this next week after the 2-week break, thermodynamics. This is specifically thermochemistry, which is a field where we want to measure the heat evolved when reactions occur. Now, what I'm doing today are not really reactions. They're just they're dissolving something in water to see what's the energy either consumed or released when a salt dissolves. I'll be dissolving KOH, potassium hydroxide, in one trial, and in the second trial I'll dissolve potassium chloride, KCl. One is going to involve an increase in temperature, so will be called exothermic. The other will involve a decrease in temperature, which we call endothermic. So I have a little picture here of what's going on. This is called coffee cup calorimetry. So I'll show you the actual device in a second, but here's the basic theory. You might want to pause this just to look at the what I've written here on this page. But a coffee cup calorimeter is essentially styrofoam cups that have a cover on it, so it's done at constant pressure. So the heat that we measure we can call enthalpy, which is this delta H here. I have a temperature probe, which is just a fancy thermometer that's connected to a computer. I'll have a cardboard cover that I'll show you. I'm going to fill it with some room temperature water, and then I'm going to throw in some salt, KOH or KCl, in separate trials, and they're going to dissolve according to these equations. And I'm going to measure the change in temperature, which is called delta T. I'll explain in more detail what these terms are in another video, but we know the correct answers. When KOH dissolves, we know it evolves 55,000 joules per mole. And when potassium chloride dissolves in water, it evolves a positive 18,000 joules per mole. So those are, we'll consider the correct values. And the goal of this experiment is to see if you can recreate that data, if we can together, and see if we can get those values by using a rather crude device, which is just a couple of styrofoam cups. The equation that I use I'll cover again in more detail in another video, but it's the mass of the solution times what's called the specific heat times the change in temperature. That's the heat evolved, and enthalpy is how much heat is given off or consumed per moles of substance, in this case the salt, the KOH or the KCl. And it turns out it's in units of joules per mole. So this is what the coffee cup calorimeter looks like. It's just a couple of nested coffee cups. This one's a little smaller than this one. It's pretty crude, but it works. And I just cut a little cardboard cover off to fit on top, and I put a little hole in it so that my temperature probe, which looks like this, it's a digital thermometer, and it's attached to the computer. We're using LoggerPro software, which is real nice to use for acquiring data. It's connected to this interface here, and it goes into my computer here, and I have the LoggerPro software opened up. It might be hard for you to see the screen from this vantage point, but I'll zoom in once I start acquiring the data. So what I'm going to do is acquire some data, and here's some of the data that I'm going to acquire. So in trial 1, I've weighed out, the best I can do with the balance I have at home is 1 decimal place, so I have about 3.0 grams of KOH, which I'll have to convert to moles later. The volume of water is 100.0 milliliters, but in this equation I have to use grams. In this equation, mass is grams. That's the mass of the solution, the water. So it's very easy to convert 100 milliliters of water to grams. You just multiply the volume times the density, which we'll assume for water is exactly 1. So we get 100.0 grams. 100.0 milliliters is exactly equal to 100.0 grams. That's what we'll assume. This C term in this equation here is called the specific heat, and we're going to assume that even though I have salts dissolved in the water, that it's mostly water, so the heat capacity of that solution is pretty much the heat capacity of water, which we've known for a long time. It's been measured. It's 4.184 joules per gram degree C. What that number means is if you want to change the temperature of 1 gram of water by 1 degree Celsius, you have to add in 4.184 joules. That's a very precise number. So the graph I'm going to acquire will look like this. This would be a exothermic reaction. My initial temperature I'll measure, I'll throw in the salt, I'll mix it up, it will rise to another temperature because heat will be given off to the solution, to the water. And I'll measure the change in temperature as a delta T. And that's how I'll get the delta T here. So this term here, this delta T, I'm getting from this Logger Pro software here. So you may have a hard time seeing this, but all I'm going to do, I've let this come to room temperature. Now I'm in my basement, so it's a little chilly down here, but I'll pour all that water into there. I'll put that aside. So I have 100.0 grams of water, and I've weighed out my KOH, about 3.0 grams. It's just a white solid. This is the same stuff that they use in Drano. It's kind of nasty stuff. So I'm hoping it isn't sticking too much to this little dish, and I'll grab a spatula so that I can get it in there quickly. I want to transfer it quickly to the solution. So let's take a crack and see how we can do. Now I want you to watch the screen, and I'll zoom in. But here I have the temperature probe. Now normally in a lab we would put this on a ring stand. I'm just going to put it in a beaker so it doesn't tip over, and I'm going to swirl it when I add the salt. So for now I'm just going to kind of hold it here, and I'm going to start the software. So I've set it for about 10 minutes. You might have a hard time seeing that, but on this screen over here I've set it for 10 minutes collection. The temperature as a function of time is going to come out here. It should appear as like a green line. So I will start, and let's see what temperature. We're at 16.4 degrees C. You can kind of see it here. Let me see if I can zoom in. I should be able to do that while I'm running this video. Maybe move the camera a little bit. So there you go. Now what I want to do is acquire a baseline. So I want to acquire about, I don't know, 100 to 200 seconds of room temperature. What is room temperature down here is a little chilly. So while I'm doing that, I'm going to get my KOH ready and make sure it's all going to get transferred quickly to the solution. It's absorbed some moisture from the air, but it should all get transferred. I'll do my best here. You want to do this quickly because I want to make sure that I don't have the top off the calorimeter for too long. So let's just keep going here. You can see it's around 16.4 degrees C. Here's my coffee cup calorimeter. So here's what I'm going to do. Now the graph is going to probably take a little dip or something while I'm transferring the solution, but I'll see if we can do this quickly. I'll dump it all in as best I can. Okay, it's sticking a little bit to the dish, but I got most of it in there. Okay, let's get that in there. We'll put the top back on, and now we'll start mixing. Now you can see that the temperature is going up. Okay, let's see. Now normally we would be stirring this. Now it's being it's not going up nice and smooth because this is a somewhat crude device. But let's just see how this goes. What I'm really looking for is not really how it gets there, but the maximum temperature it's going to reach. Now a little bit is spilled out here, that's okay. I'm over mixing it a little bit, a little overzealous. Let's keep it going. It's still rising. You can kind of see what I'm doing here. This would be, like I said, on a hot plate, and I would be mixing it. It looks like it's dissolving. Now again, this is a basic solution, so I got to be careful. This is not, excellent lab procedure, but I'm in my basement trying to acquire some data here, not really in a lab setting. And the temperature appears to be leveling off. Let's just see what it does here. I think it's all dissolved, so I will just let it sit here and see what happens to the data. Maybe when I run the next trial with KCl, it will be a little bit more of a steady increase. I got a little bit of water leaking out here, actually KOH solution. That's okay. You wouldn't want to get that on your skin, so to speak, but so again, I think we've reached a constant temperature. Let's just give it about 30 more seconds and see if it goes up any more. I'll gently swirl it. Part of the problem is I'm using KOH that has been in our stock room for probably almost 3 years, so it's absorbed a lot of CO2 from the air. So it isn't the best, and you can see some of it actually stuck to the pan. It absorbed moisture in my somewhat kind of damp basement. So this isn't a great trial, but I think it's accomplishing what I want you to see. And the temperature's going up a little bit more. Let's just give it another minute or two. So I'm going to have to post the trial 2 when I'm running KCl, potassium chloride, instead of KOH in another video. I'm already at 12 minutes, so I know this video will not fit on Canvas directly. I will have to upload this to YouTube. Okay, it's still rising. It's going up even more now. I know about what it should rise to, so now it's actually looking better. Even though this curve, as you can see, is real jagged. In theory, in a perfect world, if I perfected this, if you were running with better equipment, you would see the graph look like this, a nice smooth rise. And eventually, if I ran this enough times, I would probably get it to do that. But I have limited material here at home, and I only have maybe enough material that I took home to run a couple trials, so I want to conserve it. I'll try it again and see if we can improve it. But for now, this trial is looking okay. Let's let it go to 400 seconds. Let me just gently mix it a little more here and see if it goes up any more. I'm assuming it's all dissolved in there. The point is to 100% completely dissolve the 3.0 grams that I used. And see, the temperature's starting to drop, so I'm going to stop here. And let's see how we would process this data. So what we would do is, here's our initial temperature. Let's assume that this is our final temperature somewhere in here. What I can actually do is kind of take an average of them. But I'll go to let me zoom in a little bit on the screen here and maybe adjust the camera a little bit. So you can see, you can see the temperature here. If I go to Analyze, Examine, a cursor will pop up where I can scroll through. And you can see that my initial temperature before I poured in the KOH was 16.4 degrees Celsius. So again, I'm in a basement. It's a little cold, but that's my initial temperature. That would be this T sub I here. So we'll call that 16.4. You'll record that in your data table. And the final temperature that we reached, the highest temperature that we got, was somewhere in the region of 19.6 degrees C. Technically, I should probably average all these, but I know it should rise up a fair amount. So I'm going to just call this T final, 19.6 degrees Celsius. That's your TF for this particular trial here. So there's that. Here's the perfect graph, in a perfect world. Here's our graph. So you can see in real experiments you don't always get data to look perfect, because there's a lot of experimental error here with this somewhat crude setup. But again, to summarize, the final temperature went to 19.6 degrees Celsius. The initial temperature was 16.4 degrees C. So again, this is just all I have again is 2 nested coffee cups. And it's like a thermos with a cover on it to kind of keep the heat in. So in the next video, I will show you how to process this data. There'll probably be 4 total videos. 2 videos for each trial actually run down here, and 2 videos, or maybe possibly 1, to show you how to do the math for your report.